transforming the graph of an exponential function. In order to talk about transforming a graph, we need a graph to start with. So let's take a look again at the f of x equals 2 to the x, the simplest exponential function I know of. And there are three different things that we could do to transform a graph. We can multiply by a coefficient. For example, f of x equals 3 times 2 to the x. And just like transformations you've seen in the past, if we want to take the transform 3 times 2 to the x, we'll multiply all of our y values by 3. So our horizontal asymptote, well, 3 times 0 is still 0. That's really going to be challenging. So we still have a horizontal asymptote at y equals 0. Negative 1, 1/2. If we multiply 1/2 times 3, we get 3/2. 0, 1. If we multiply 1 times 3, we get 0, 3. And 1, 2. If we multiply 2 by 3, we get 1, 6. Right? So our points are much steeper now, but the shape is still going to look the same, and it's still going to have this horizontal asymptote that it eventually shifts down towards. If I grab this thing, and let's copy over my original function so we can still keep working with the same f of x equals 2 to the x. And this time let's add something. And we can either add inside the argument or outside the argument. Let's take a look at f of x equals 2 to the x minus 1. Right? Our addition, in this case subtraction, outside of the argument of the function means that it's going to affect the y values, and things affect the y values directly. So we want to subtract 1 from each y value. And immediately things get interesting. Because if we subtract 1 from the y value of y equals 0, we get that the horizontal asymptote this time is y equals negative 1. If we subtract 1 from the y value in negative 1, 1/2, we get negative 1, negative 1/2. If we subtract 1 from the 0, 1, we get 0, 0, the origin. And if we subtract 1 from 1, 2, we get 1, 1. So our entire graph shifts downward by 1, which is exactly what we expect thinking about the way transformations of graphs work. A key thing that happens here, domain of an exponential function is always all real numbers, but the range, instead of being all positive numbers, now is all the numbers bigger than negative 1. Written in interval notation, the range is the interval from negative 1 to infinity. All right, let me grab this original function one more time, and we'll look at the third kind of transformation. We looked at multiplying. We looked at adding or subtracting outside of the argument. Now let's look at adding and subtracting inside the argument. Right? Changes that happen inside the argument affect the x values, not the y values. And changes that happen inside the argument affect the x values backwards of how you would initially think. So by adding 1 to the argument, we have to subtract 1 from each of the coordinates. It doesn't affect the horizontal asymptote, but instead of -1 1/2, we will now have -2 1/2. Because if we took -2 plus 1, we would get -1, and 2 to the -1 power is 1/2. Likewise, 0, 1 is now going to move to -1, 1, and 1, 2 is going to move to 0, 2. So the picture slides over slightly, but it's the same basic shape yet again. And that gives us this transformation on the graph. Right. To make things more complicated, we can apply 2 or all 3 of these transformations to a function at the same time. And then when that happens, just take it one step at a time. Apply one transformation at a time. And it turns out it doesn't matter what order you apply them in, you'll get to the same end result.